Hi guys, this is the 3.5 notes. So this is the last section of notes in topic 3. Right. This deals with something called symmetry. Okay, so reflectional symmetry, right, is a type of symmetry. So we'll go over reflectional and then rotational. It's a type of symmetry that maps the figure onto itself. The line of reflection is called the line of symmetry. Right. So, right, in these images, we're looking for a line that will cut them exactly into two symmetric shapes, right? So if we look at the first image, right, if we draw a line straight up through vertically, you can see the left side is an exact reflection of the right side's image. All right. Same thing for the next one. If we make a vertical line through this, right, we can see the left side is a reflection of the right side. The last image, we can actually do a horizontal line, or we can do a vertical line through the middle. Either one, right, makes a reflection over that line to the other side, making it symmetric. All right, so right, this is reflectional symmetry. The next one is rotational symmetry. It says a type of symmetry that maps an image onto its pre-image after a rotation of less than 360 degrees. So, right, that means we can rotate our image, right, some degree that will map it to the same exact spot. Okay, it looks the same. Okay, so rotate so that image stays looking the same. Right, so, right, the triangle, right, if we just kind of rotate it, so we move this point to here, right, here to here, right, we can do that, right? That means it has rotational symmetry, right? And then we could do it again, right? We could do it all three parts, right? So we can rotate this 3 times. This one we can see there's kind of six, 6 of the same looking pieces, right? So we can rotate this 6 times. Right, and the last one, right, we have 3 same images, so we can rotate that 3 times. Okay, so all of these have rotational symmetry. And then our last piece of symmetry would be point symmetry. A point symmetry is a type of symmetry where an object has rotational symmetry of 180 degrees. Okay, so, right, essentially you take a point and you're flipping it, right, 180 degrees, and it stays in the same looking shape. Right. Some things that have point symmetry that are easy to see are certain capitalized letters. We can think of I. Right. Say we drew our I like this and we rotated 180 degrees. Right. It would stay the same shape. Right. It'd still look I. There are a couple others, right? H, O, X, and S. Right, if we rotate them 180 degrees, they're going to land and look the exact same capital letter that you're given. Okay, so point symmetry is 180 degrees. So in this example 1, what we're going to do is we're going to figure out which lines we can create, right? We can put or rotate or things like that to map this onto itself, right? First, we'll think of line symmetry. Well, if we put a line here, it will map to itself. If we put a line here, it should map to itself. And also, right, if we did 180 degrees, right, rotation, it would also map to itself. So vertical line, horizontal line, and 180-degree rotation. And then B, right? Well, one thing we can do is we can make a vertical line, right? So the eyes reflect and the mouth. Okay, so vertical line. But right, if we rotated that, right, our eyes would be on the bottom and it wouldn't look the same image, right? It needs to be the same exact image. The next example is finding how many lines of symmetry does a shape have. Okay, so right, this hexagon, right, we could cut it in half this way. We could also cut it in half this way. We could cut it in half. Oop. Sorry, not that way. But right here, we can see that would cut in half. Right here, that would cut it in half. And also at the corners. Right. There's our fifth line, and then we can see a sixth line. Therefore, right, because we can have reflection over 6 lines, right, we have 6 lines of symmetry. All right, now what we can do is we can determine if the following letters have point symmetry, right? Remember, we said there's certain block letters that we can have point symmetry, and point symmetry tells us we can flip it 180 degrees. Okay, so we can tell if it has point symmetry. We can also tell if it has line symmetry as well, or if we can draw a line of reflection through them. So if we look at X, right, I could cut it here, I can cut it here, right? So it has 2 lines, right? And then also I can rotate 180 degrees, so it has point symmetry. Right? If we rotated X 180 degrees, right, we know that it's going to land on the same spot. Now M, right, if we rotate it 180 degrees, it's not going to work. It's going to look like a W. But we can draw a line here that cuts in half, so it has one line. S, right, we can't draw a line that's going to cut this and make a reflection on both sides. But, right, if we rotate it 180 degrees, it will land as an S as well, so it has point symmetry. P, we cannot draw a line, and if we rotate 100 degrees, it's not going to land there, so nothing for P. All right, now the last thing is finding the angle of rotation. So what is the angle of rotation? Well, first it has angle symmetry. Rotational symmetry. Right? Meaning, right, we can spin it and it's going to land on itself, right? And if there is rotational symmetry of 180 degrees or less, right? So it has rotational symmetry of 180 degrees or less, right? And that brings us back to some of the images that we went over before. Remember that like triangle we had the triangle with the triangles inside of it look like this. And then it looked like this. Right, and you could spin it here or all the way here, right? Okay, so that had rotational symmetry of 180 degrees or less. Okay, now to find this, what we're going to do is first find how many lines of symmetry. Right, so we're going to draw all the lines of symmetry that we can find in this picture. Right, so right, if we can cut it vertically, and we can also cut it horizontally, and we will get a reflection over those lines. Okay, so we found out, right, there's 2 lines of symmetry. Okay, now to find the angle of rotation, what we're going to do is divide 360 degrees by the number of lines of symmetry. Right, so it's going to be 360 degrees divided by n, where n is the number of lines of symmetry. Right, so right, to figure out this example, if we look at it, right, if there's 2 lines of symmetry, n equals 2, therefore our angle of rotation is equal to 360 degrees divided by 2. So our angle of rotation is 180 degrees. So it has rotational symmetry, and angle of rotation is 180 degrees. Right, because there's 2 lines in this example. All right, so why don't we look at these 2 examples together, and let's figure out if there is point symmetry, and if there's angle of rotation. Okay, so remember, point symmetry is 180 degrees. Angle of rotation is 360 divided by the number of lines of symmetry. Okay, so if we look at the equilateral triangle right here, right, we can cut it here. We can also cut it vertically in half, and we can also cut it this way. So n is equal to 3. So angle of rotation, 360 divided by 3, which equals 120 degrees. The next one's a parallelogram. The way we can cut this is at the corners. We have one cut there and one cut here that will make perfect symmetric shapes over those lines of reflection. So our n is equal to 2. Therefore, our angle of reflection is 360 degrees divided by 2, which is 180 degrees, which means it has point symmetry. All right, and that's the end of the notes.